ISO ISO-OSI model is ISO-OSI architecture. The ISO was one of the first organizations to formally define a common way to connect their arch- uh, computers. Their architecture called the Open System Interconnection (OSI) defines a partitioning of network functionality into 7 layers. The OSI model has 7 layers. The principles that were applied to arrive at the 7 layers can be briefly summarized as follows. The first one, a layer should be created where a different abstraction is needed. Each layer should perform a well-defined function. The functions of each layer should be chosen by defining internationally standardized protocols. The layer boundaries should be chosen to minimize the information flow across the interfaces. In this figure, shows the layered systems with alternative instructions available at a given layer. The OSI model has 7 layers. First one, physical, data link, network, transport, session, presentation, application. Functions of different layers. First layer, physical layer. It physical layer. It is the lowest layer of the OSI model. It activates, maintains, and deactivates the physical connection. It is responsible for transmission and the reception of the unstructured raw data over the network. Voltages and data rates needed for transmission is defined in the physical layer. It converts the digital and or analog bits into electrical signals or optical signals. Data encoding is also done in these layers. In second layer is data link layer. Data link layer synchronizes the information which is to be transmitted over the physical layer. The main function of this layer is to make sure data transfer is error-free from one node to another over the physical layer, transmitting and receiving data frames sequentially and is managed by this layer. This layer sends and accepts acknowledgement for frames received and sent respectively. Resending of a non-acknowledgement received frames is also handled by this layer. This layer establishes a logical layer between two nodes and also manages the frame traffic control over the network. It signals the transmitting node to stop when the frame's buffers are full. Then third layer, the network layer. It routes the signal through different channels from one node to other. It acts as a network controller. It manages the subnet traffic. It decides by which route data should take. To decide by which route data should take, it divides the outgoing messages into packets and assembles the incoming packets into messages for higher level. Then layer 3, transport layer. It decides if data transmission should be on the parallel path or single path. Functions such as multiplexing, segmenting, splitting on the data are done by these layers. It receives messages from the section layer above it, convert the message into smaller units and passes it on to the network layer. Transport layer can be very complex depending upon the network requirements. Transport layer breaks the message or data into small units so that they are handled more efficiently by the network layer. Then fifth layer, section layer. Section layer manages and synchronizes the conversion between two different applications. Transfer of data from source to destinations. Session layer streams of data are marked and are resynchronized properly so that the ends of the messages are not cut prematurely and data loss is avoided. Then sixth layer, the presentation layer. Presentation layer takes care that the data is sent in such a way that the receiver will understand the information or data and will be able to use the data. While receiving the data, presentation layer transfers the data to be ready for the application layer. Languages or syntax can be different of the two communicating system. Under this condition, presentation layer plays a role of translator. It performs data compression, data encryption, data conversion, etc. Application layer. It is a topmost layer, transferring of files, disturbing the results to the users is also done in these layers. Mail services, directory services, network resources, etc. are services provided by the application layer. This layer mainly holds application programs to act upon the received and to be sent data. Merits of OSI model. OSI model distinguishes well between the services, interfaces and protocols. OSI model distinguishes well between the services, interfaces and protocols. Protocols of OSI model are very well hidden. Protocols can be replaced by new protocol as technology changes. Support connection-oriented services as well as connection-less services. Supports connection-oriented services as well as connection-less services. In the demerits of a OSI model. Models was devised before the invention of protocols. Fitting of protocols is a tedious task. It is just used as a reference model.